The universe is vast and silent. For generations we've listened for a sign that we're not alone. Our radio telescopes have scanned distant stars, but the cosmos has remained quiet, until now. The James Webb Space Telescope detected an object moving strangely about 10 light-years away, shifting its path toward us. While astronomers tracked that distant anomaly, Webb focused on a visitor already within our solar system. This wasn't a spaceship, but something even more ancient. A comet from another star system named 2I/Atlas. 2I/Atlas is a relic from a place we've never seen, carrying secrets from a star we do not know. Its arrival is a rare chance to study a piece of another solar system right here. Most comets are local, but 2I/Atlas is different. Its speed and trajectory prove it's just passing through. As it neared the sun, it began to reveal secrets that would challenge everything we thought we knew about life and the universe. The distant maneuvering object was just a teaser. The real story was unfolding with 2I/Atlas. This unassuming ball of ice and rock became the focus of intense scrutiny. Scientists worldwide held their breath as Webb prepared to take a closer look. Would it be just another chunk of frozen rock, or would it carry the answer to humanity's oldest question, are we alone? The universe was about to give us a clue, one more astonishing than anyone could have predicted. To grasp the importance of 2I/Atlas, imagine our solar system as a cosmic family, planets, asteroids, and comets all born from the same cloud. But 2I/Atlas is an outsider, ejected from another star system, wandering the void for eons. Interstellar objects like this are rare. Before 2I/Atlas, only Oumuamua had been confirmed. Its arrival gave us a fleeting chance to study a piece of an alien world. Detecting such visitors is difficult. They're small, dark and fast, only visible when close to the sun. Astronomers at the Atlas survey first spotted this faint traveler and quickly calculated its trajectory. The math was clear. 2I/Atlas was moving too fast to be captured by our sun, destined to swing by and vanish forever. The 2I marks it as the second interstellar object ever found. Atlas honors its discoverers. Unlike comets from our Oort cloud, 2I/Atlas is on a one-way trip. A cosmic gift, a time capsule from an unknown place. It carries the chemical fingerprints of its home system, and as we'd soon learn, much more. This was not just another rock. It was a messenger from the interstellar deep. The stage was set for our most powerful telescope to take a closer look. Our window to unlock its secrets was brief. Scientists prepared to capture every possible detail. The world waited for what 2I/Atlas would reveal. To study a faint, fast-moving object like 2I/Atlas, we needed the James Webb Space Telescope. Floating a million miles from Earth, JWST's gold-coated mirror captures faint infrared light, perfect for cold objects like comets. When 2I/Atlas came into view, Webb did more than take pictures. It performed spectroscopy, splitting the comet's light into a chemical barcode. This allowed scientists to identify exactly what the comet was made of, down to the tiniest trace. Webb's mission: analyze the coma, the cloud of gas and dust released as the comet neared the sun. As the ice vaporized, it revealed materials frozen inside for eons. Webb searched for water, carbon dioxide, and anything unusual, anything that didn't fit the profile of a typical comet. The observations were a race against time. 2I/Atlas was moving fast, and its closest approach was our best chance. Teams worked around the clock, collecting every photon. The data streamed back spectral lines and infrared images, a treasure trove for astrobiologists. As astronomers pieced together the puzzle, awe and disbelief grew. The chemical barcodes were unlike anything seen before. The interstellar visitor was beginning to tell its story. The first results from Webb's analysis of 2I/Atlas were stunning. The comet contained water, ice, and dust, but also complex organic molecules. Long, structured chains resembling the building blocks of life. Patterns looked strikingly similar to amino acids and lipids, suggesting an organizing process, not random chemistry. These molecules were unusually stable, resisting the sun's heat and radiation. It was as if something inside the comet was preserving its complex chemistry. Webb also found nitrogen compounds that appeared biologically processed, signatures matching those of living organisms on Earth. Isotopic ratios in the comet's water and organics were different from any solar system comet, hinting at biological activity. The comet's coma glowed green and red. The red suggested tholins, complex organics considered precursors to life. The combination of stable organics, processed compounds, and tholins painted a picture of a comet far more than just rock and ice. 2I/Atlas was behaving in ways that defied our understanding. The evidence was mounting. This was no ordinary visitor. The universe had delivered a mystery wrapped in chemistry. Beyond its chemistry, 2I/Atlas behaved in ways that baffled astronomers. Its jets of gas and dust pulsed in rhythmic, irregular bursts, almost as if the comet were exhaling. Unlike fragile comets that often break apart, 2I/Atlas remained remarkably intact, its nucleus holding together against powerful forces. This resilience suggested a structure far stronger than simple ice and dust. Its surface temperatures didn't match what sunlight alone could explain. Some areas stored heat, others cooled unpredictably. This hinted at internal heat generation, possibly even pockets of liquid water beneath the crust. Most bizarre was the hint of a localized magnetic field, strong and focused around the nucleus. Such a field is unheard of for a comet, adding another layer of mystery. Pulsing jets, unusual strength, strange temperatures, and a magnetic field, 2I/Atlas was acting more like a complex dynamic system than a simple snowball. The comet's behavior challenged every model astronomers had. Was it a natural oddity, or something more? The questions only deepened. The extraordinary data from 2I/Atlas ignited fierce debate. Some scientists urged caution, suggesting exotic chemistry could explain the comet's features. Unique ices, unknown minerals, or temporary magnetic effects. Extraordinary claims require extraordinary evidence, and the idea of alien life is the most extraordinary of all. Perhaps 2I/Atlas came from a star system with chemistry unlike anything we know. But astrobiologists argued that biology was the simplest explanation for all the anomalies combined. Rhythmic jets resembled respiration. Stable organics looked like metabolic products. Processed nitrogen and isotopic ratios were classic biosignatures. Internal heat and structural integrity could point to a biologically reinforced structure. Was it more likely that all these features were unrelated chemical flukes, or that they pointed to life? The debate forced us to confront our biases and expand our imagination. Whether chemical marvel or living ecosystem, 2I/Atlas was the most important object ever studied. It challenged our definitions of life and our search for it. The mystery was far from solved. The discoveries from 2I/Atlas revived the ancient idea of panspermia, the theory that life can travel between stars on comets. For years, panspermia was dismissed as science fiction. Space is harsh and survival seemed impossible. But 2I/Atlas's stability and possible internal heat suggested its interior could shelter life for eons. Shielded by ice and rock, a subsurface ocean or slush could protect microbes from cosmic dangers. If 2I/Atlas is biological, it's the first direct evidence for panspermia. Life might not be confined to planets but could exist in the darkness between stars, using comets as vehicles. Could life on Earth have been seeded by a comet like 2I/Atlas? This idea changes how we search for life. Perhaps we should look for life on the move, not just on planets. The galaxy could be teeming with life-bearing comets, making life spread far more likely. The debate over 2I/Atlas is also a debate about our own origins. Are we the descendants of interstellar travelers? The revelations from 2I/Atlas sent shockwaves through science and the public. Every telescope on Earth and in space turned to study the comet before it vanished. There's talk of launching a rapid response probe to intercept 2I/Atlas and collect a sample. For the public, the idea of finding evidence of alien life on a comet is a profound moment. It sparked wonder, debate, and a new sense of possibility. But it also brings caution. If comets can carry life, we must consider planetary protection and the risks of contamination. This discovery marks a new chapter in our exploration of the universe. Like Galileo's first telescope or Hubble's distant galaxies, we're forced to redraw our cosmic map. 2I/Atlas reminds us that the universe is stranger than we can imagine. Whether it's a living ecosystem or a chemical marvel, its legacy is secure. It's pushed the boundaries of knowledge and inspired bigger questions. Our journey to understand this interstellar visitor is just beginning. The cosmos is alive with mystery, and our story is far from over.